Would you like to learn the cosine rule well? Then keep watching. G'day, welcome to Crystal Clear Mathematics, where it is easier than you think. I'm your host, Graham Henderson. When we're learning to study triangles that do not contain a right angle, there are three formulae we need to know, three trigonometric formulae. The first is the sine rule, second is the cosine rule, and the third is the area rule. In this video, we're going to learn how to memorise and learn and use the cosine rule effectively. Now, interestingly, for all three rules, we start with the same diagram, and here it is. We draw a triangle that does not contain a right angle and label its vertices A, B and C. By convention, the side opposite A has length A, the side opposite B has length B, the side opposite C has length C. Remember, this is the entire length. And we draw an altitude or a height, and we'll call it H. Now, unlike the previous two formulae, I've already prepared those two videos. To derive the cosine rule, we need to split this length, this base, into two parts. We'll call this length x, which means that this length, which makes up the whole length c, must be c minus x. That is, the two of them add up to c. Now, the cosine rule, interestingly enough, is, I should show you these differently, is really a trigonometric form of Pythagoras Theorem. And the reason I enjoy deriving this is because it drives into your mind the understanding that Pythagoras' theorem is the secret behind the cosine rule. So it's no secret that it comes out looking like Pythagoras' theorem. What is Pythagoras' theorem for this right angled triangle on the left hand side? Well, it's the square of the two short sides adds up to the square of the hypotenuse. So it will be h squared plus c minus x squared equals b squared. So this squared plus this squared makes this squared. What about this side, this triangle? Well, h squared plus x squared must make this hypotenuse squared. So h squared plus x squared equals a squared. So it's more than a derivation, we just write Pythagoras' theorem for both the small right angled triangles. Now, straight away you notice that both of these have an h squared in them. So we can eliminate that because we don't want h in our result. So, what's h squared equal to? If I take this over here, h squared is equal to b squared minus c minus x squared. If I do the same with this equation and get rid of the x squared, I have h squared equal a squared minus x squared. Now if h squared equals that and h squared equals that, and we've only got the one h in the equation, in the diagram, then these must be equal. So b squared minus c minus x all squared must equal a squared minus x squared. Now let's expand both sides. Well, we really only have to expand the left. B squared minus, I'll use parentheses, c squared minus 2cx plus x squared equals a squared minus x squared. Removing the parentheses, noting there's a minus sign in front, it's very important to notice this, we get b squared minus c squared plus 2cx minus x squared equals a squared minus x squared. Now this seems like a little bit of a jumble, but just remember that it was really just Pythagoras' theorem, and remove the h squared. We get to this and notice there's a minus x squared on both sides, so we can remove them by adding x squared. And I'm going to bring the c squared over here, so I'm going to leave the b squared. I'm going to have the a squared here, bring the minus, add c squared to both sides, and I'm going to subtract 2cx from both sides, and that now is the form of the equation. I've run out from the bottom of the board, so I'm going to write it up here on the left, on the right hand side. B squared equals a squared plus c squared minus 2cx. Now you can see this looks like Pythagoras' theorem, doesn't it? Exactly. But it has another term to adjust for the fact that we don't have a right angle in this large triangle. The problem is we have the formula with an x in it, and we really don't want to talk about a fraction or a portion of one side. So looking at this triangle on the right, what ratio can we use to relate x to the side that we do know, that is the complete length A? Well, I think you can see that when we're comparing with the angle here at B, we have the adjacent and hypotenuse, and that's the cosine. So we can say, but cosine of B is adjacent over hypotenuse x over A, which means when I multiply both sides by A, that A cos B equals x. And that's what I substitute in here. So we had to go back to the right-hand triangle to get this trigonometric information to insert, and now we can write this out as b squared equals a squared plus c squared minus 2. Now it's c times x, and since x is worth this, c times this will be ac cos b. And there is our cosine rule. Now, because of the constraints of the size of my whiteboard and so on, I haven't been able to derive it fully down the page. I could do it on paper, but I prefer standing here and showing you. So we've had to sort of do it in two columns, as it were. This pattern is a very, very important one. Notice that the side here has the same letter as the angle here. So in other words, if we're using angle B, we can use it to find side B. If this was cos of A, this would have to be A squared. If we were in some triangle where that was cos of Q, this would have to be Q squared. These must be the same letter. And I hope you notice that these letters are the same here. This pattern is universal. I will rub this out now. So if you had a triangle without a right angle, and let's call the corners Q, or the vertices Q, R and K. This side would be side K, this side would be side Q, this side would be side R, and all that remains is for us to choose an angle and a side opposite. Now if I want to do it relating to K, this is the angle I'm using, and it means that these are the two sides I use. And this is the pattern I look for. I hope you can see it looks like a letter C sitting on one of the corners. C for cosine. And all I would write, I'd start with K squared, and then it would be Q squared plus R squared minus 2QR, because they've got to be the same letters, times cos K. That's the way it's derived and written. How would you learn it well? You would learn it well by setting time aside without distractions, because you can focus and learn quickly that way. deriving this one might take you 2 or 3 or 4 minutes, but deriving it perhaps once every afternoon for as long as it takes. It might only be 2 or 3 or 4 afternoons. It could take you a week and a half. But just every afternoon, spend 2 to 4 minutes deriving it and then use it. Use this to solve at least 1 or 2 questions. And at the end of that time, you should be able to ask yourself, this is after you've set time aside and after you've derived and used the formula, you ask yourself, do I understand it well enough? Am I fast enough? And if you've done enough of this work, what we call massed practice or intensive practice, you'll say, yes, I do understand, I can use it, and I am fast enough. You then ask the third question, how long before I'm likely to forget? Because forget you will. Now, it might only take 2 or 3 weeks. It could take 10 years or 30 years, but somewhere along the track you'll forget because you haven't used it. Now, most students, when they first learn this, will probably remember it for 2 or 3 weeks or 4 to 6 weeks, somewhere in there. So use your diary, put a little entry in your diary to remember or remind yourself to derive and use this formula again in that number of weeks' time. And if you use your diary to keep reminding yourself before you forget, you will end up remembering it for a very, very long time indeed. So there it is, Cosine Rule. I hope it's helped, and thank you very much for watching. And please remember to subscribe.